Hello. Hello.
Yeah.
So you can start the session now, sir.
Okay. Hello. So, can you hear me?
Yeah, sir, we can hear you. Yeah.
Okay. So, good afternoon or good morning or whatever, wherever you are in the world. I think, yes, we have a distributed audience. So, I would take you through a session on artificial intelligence. And today, all of us are hearing of AI and the magnificent things that can be done by AI. What has happened, unfortunately, is that a lot of hype and reality has got mixed. And what I would try in this session is try and bring at a very high level some clarity into what has been the real successes of artificial intelligence over the last decade, especially over the last six years, and on the other hand, what what are its serious limitations? Just as an introduction of myself, uh, I'm a group manager and a senior data scientist at IBM's Cognitive Business Digital Services Unit. I did my EPGP from IIM Bangalore in 2012-13. I am an electrical engineer by training, and currently I'm doing my PhD in machine learning, expected to complete in 2020. So I have around 10 years of experience in the fields of data science, machine learning, etc. So please put your questions on the chat, and we would take that at the end of this session. So when we look at the data that has been around in the world, in the last 3 years, we see that the data explosion has increased from 2.78 million YouTube views per minute in 2016. This has almost increased by 60% to 4.3 million. From 69,000 hours of Netflix view in 2016, in 2018 this has gone almost 4 times to 266,000. So there is a huge amount of data that is being processed by every company and each one of us also. What this means is that there is a lot of data which needs to be processed and insights made out of. And to be able to do that, artificial intelligence techniques has been playing an increasingly important role. I would like to iterate, however, that most of the methods that are there used in AI, at least their basic form exists for over 3 decades. But it is only the computational power, the high data availability, etc., which have made AI a reality in the last 5 to 6 years. When we look at the Gartner hype cycle, you would see that deep learning, which is one of the major components of AI, and I'm sure all of us have heard about deep learning, is right at the peak of the hype cycle, whereas things like virtual assistance and autonomous driving level 4, which basically means driving without a driver completely. Both of these have sort of fallen into the trap of disillusionment because the promises that were made out of them have sort of belied the expectations. However, I would like to point out that the promises in both virtual assistance and autonomous driving was based on neural networks. And neural networks would also get into a field of disillusionment in a couple of years. But then there is a lot of very real work that has happened in the last few years, which sort of necessitates that this is not a plain hype, but there is some reality in it. Now, one question that many of you would be wondering is that most of us are playing managerial roles, given that we are alumni from IIM Bangalore. So one of the things that many of you will be wondering is that is not AI something for technology specialists, computer scientists, etc. And whilst that is true, I would like to quote Harvard Business Review, and I think it's a very, very important and a valid quote. If managers aren't ramping up experiments in the area of machine learning, they aren't doing their job. And the next line is most important. Over the next decade, AI won't replace managers, but managers who use AI will replace those who do not. So I think that this is very true, and increasingly all industries are realizing there is a value for artificial intelligence. I, however, do agree that there is a lot of very mundane, even descriptive analytics that is happening under the guise of artificial intelligence. And there is a lot of experiments that people do without any intention of taking it to production. All of these are very valid scenarios all across the world now. But one thing is sure, that AI is going to replace all industries in the next few years. And we are now at the start of the third or the fourth industrial revolution, depending on how you count. The first industrial revolution was in the 1760s with the steam engine. And the second industrial revolution was in 1890s, early 1900s, with electricity. This is a poster in New York, no less, in 1920. Sorry, 1910. So just over 100 years ago, and there is an attempt to tell people that you must be using electricity. I know for all of us this sounds very absurd. We've all been born and brought up with electricity being assumed, but and even our parents. But this is true that as early as 100 years back, electricity was a novelty even in New York. AI today is a novelty, but just as electricity transformed every industry in the next 20 to 30 years, artificial intelligence is going to transform every industry in the next 2 to 3 years, next 2 to 3 decades, with some variation based on the industry and the geography. The last industrial revolution replaced human physical labor, but here is the first time when human mental labor would be replaced via this industrial revolution. So, when we look at the definition of AI, this is not there's no single definition, or there's no one answer to this. But one of the definitions which one can use is that It is a science and a set of computational techniques that are inspired by but typically operate different from the way people use their nervous systems and bodies to sense, learn, reason, and take action. I would like to point out a few very important things. First of all, it is a set of computational techniques, right? It is nothing which is very emotive or something which has a lot of physical sense around it, etc. It's just a set of computational techniques, it's a set of algorithms. And also, the latest techniques that are used in artificial intelligence neural networks, they are inspired by our human neural network. But there is no reason to believe that our human neural network work in the same way that artificial neural networks work. So while these networks are inspired by, but they do not typically operate in the same way. And also, there has been tremendous applications and success stories in artificial intelligence. Oncology, history, driverless cars, etc. All chatbots, all are powered by artificial intelligence. But we are still way away from the way we understand intelligence, even for animals. People may be surprised at looking at history. So I'd just like to mention that there has been significant work being done to use techniques which are drawn on the same principles that we use for natural language text to try and decipher the Indus Valley script. There are techniques that are being used on image processing and to look at what is inside the pyramids in the solid part of the pyramids. There is a lot of applications even in areas which seem to be very far away from artificial intelligence. So I mean we're not running this as an interactive session because it can get a bit difficult. But this is the first flight actually, which happened even before the Wright brothers. It was a short flight of a few hundred meters or less. But the important thing is that if you look at it, it looks very similar to a bird. However, current airplanes, which we all have traveled on, don't look at all like birds. The reason why I point this out is what I said in the definition of artificial intelligence, that the techniques are inspired by the nature, but they need not follow nature. Human beings have, since Greek times, put wings on their backs and jumped off cliffs to falling to their death in the hope to fly. But the way we fly today are governed by similar principles of aerodynamics, but the technology and the method by which it happens is extremely different. When we look at the history of artificial intelligence, and this sort of matches up to some extent with the history of computer science, with Charles Babbage and Ada Lovelace in 1830s designing the analytical engine, and George Boole inventing binary algebra. And there was a period when computation was much less in vogue, although there were certain computational machines like the ENIAC, EDVAC, etc. in the early part of the 20th century. But it is only Alan Turing's universal Turing machine from where theoretical grounding in the subject started coming up. 1956, John McCarthy proposed the term artificial intelligence. And then there have been bursts of success in artificial intelligence with large areas of relatively less work. One of them, and these are called the AI winters. One of them in 1960s when or 1960s, 70s, where the first AI winter sort of happened when people had thought there would be huge success stories, but they did not. And then in 1986, neural networks, which the formulation of them was done. It could be a little earlier, 1984, I think. Sorry. And the architectures of most of the common networks took place again in 1980s. And then there was again a long sort of AI winter because neural networks really did not succeed very well because you could not make them computationally efficient. Although in between, in 1997, IBM's Deep Blue beat Garry Kasparov and chess. But it is only in the last 5 years with convolutional neural networks in computer vision and the use of LSTMs and distributed representation of words in text did AI sort of pick up. And this is interesting because even in 2012, when I was a student at IIM Bangalore, AI was not a word which anybody really used with seriousness. And today it has become the sort of word that everyone is always using. Just to see, this is the Mark I perceptron. A perceptron is a very simple algorithm, and today it can be written with one line of Python code. This was an actual implementation of a perceptron in 1960, and it is used to solve binary classification tasks like whether somebody will default a loan or not. And to implement something like that, even as late as 1960, you needed something as big as this machine. Now, one thing we must be very careful about that artificial intelligence does not mean deep learning. Deep learning is a small part of artificial intelligence. There are various other parts like traditional machine learning and then representation, knowledge bases where you have a knowledge of the world, AI planning, etc. So AI is not just deep learning, although it does form a huge part in the success of AI in the last few years. So, and I see there are a lot of people who have lots of misconceptions between what is machine learning, what is deep learning, and AI. I would like to say that as a technologist, the principles behind them are not very different. And then that's very important to understand. The way they work is not very different. Machine learning itself is again the field of computer science that gives computers the ability to learn without being explicitly programmed. This is important because when we look at traditional IT development, it may be a very complex piece of code. It may be running in thousands or millions of lines of code, but it basically is a declarative, deterministic rule which says how to process the data. So your income tax computation may be a very complicated rule, but there is nothing statistical or probabilistic about it. Maybe thankfully so. However, machine learning is very different. The reason is that we do not really know the algorithms for identifying these. When we look at why people default on a loan, there is no algorithm to understand this, and machine learning techniques identify this from the data. When you are looking at my video on your WebEx, you have no way to explain what is the algorithm that allows a few light beams falling on the retina of your eye in an inverted way, makes you realize what you are looking at, what you are reading, etc. The algorithm is not known, and perhaps there is no such deterministic algorithm. And therefore, machine learning is where we try and learn the patterns from the distribution in the data. And this is why it is data science. There is both the data, which is core to the problem, but it is also a science because your objective is to learn distributions from the data. So, how does a computer, when we are talking of AI systems, which is able to identify different objects visually. This includes your driverless car. This includes your automated surveillance. But it also includes, in some ways, the face identification when you are taking a selfie. These are also AI systems. Some of them may be more traditional computer vision algorithms. Some of them may be deep learning based algorithms. Your driverless car may work in a slightly different way from the way your phone is identifying your face or the face of any other person on the selfie. But in many ways they are similar. They are dependent on distributions of the data on the image, right? And this is very obvious when you look at the picture of the cat and the dog, right? And if you are to explain it, there are two things that we see that there are certain boundaries of both the cat and the dog. There are a lot of things which are common within the boundary. And again, there are things like the eyes and the whiskers or the tongue of the dog, or the whiskers of the cat, which sort of stand out. And the way a selfie would identify this is to identify these distributions of the images. So, picture in a computer is just an array of numbers. And this is a snippet from some picture which I picked up. And you see it has three different columns, which are the red, green, blue channels. And then you have lots of pixels. And each pixel is defined by a RGB value, or the red, green, blue value. Now, because we are not aware of any algorithm to identify a cat, we use machine learning. And specifically, we use a technique of a class of machine learning algorithms called supervised machine learning. What is this? You give a computer thousands of pictures of cats, dogs, boys, etc. And for each of them, you label it. So you take the historic data and you label it in that image, whether it is a cat, a dog, or etc. There could be images where there is both a cat and a bus, or a boy and a dog, and in that case, you would need to label that image with where is the boy and where is the dog. We then apply certain algorithms. We try and find patterns which are common between cats, and patterns which distinguish cats from dogs. Now, it is important to note that our entire objective in supervised machine learning and deep learning is at least the greatest success stories of deep learning have come from supervised machine learning techniques. So there are certain others in a different class of problems. These cats and dogs, you need this data. And the advantage that we have got in the last few years is that you have lots of labeled data from the internet. You can get lots of data and have people going in and manually annotating them. This could be people in your organization, or it even could be crowdsourced using tools like Amazon Mechanical Turk, etc. So basically, you have this labeled data where you tell in each picture whether there's a cat, a dog, a human being, etc., or many of them. And then you let the model learn. You use certain techniques to ensure that your model does the proper thing, techniques which have fancy names like cross-validation, hyperparameter tuning, regularization, etc. But the hope is that it would be able to do a good job when it sees a new picture, but then sometimes it does not. When it looks at the pictures like these, well, it may, in many cases, not be able to identify very well whether it is a cat or a dog. And a cat and dog are just examples. Well, this is a very, very 10,000 feet view of how you make a computer see. Making a computer talk is perhaps even more difficult. This is because human language is specially constructed to convey the meaning, and often this is complicated because unlike the picture of the cat or the dog where we saw that the dog was white in color and more or less all through the dog it was white, there was a continuous area and there was a boundary where the colors changed. Similarly for the cat, it was brownish in color except near its eyes or at the background. However, when we look at words, the violin and the guitar are from a linguistic sense. Although musically they may be quite different, but from a linguistic sense they are the same class of words, nouns, and the way we would use them in a sentence won't be very different. But they're practically nothing in common, with rare exceptions like wua, etc., where you try and place emphasis. The letters do not convey any information about the word. It is also that speech has the problem that there is a lot of context that is required for us to understand speech, right? When I'm talking here, there are many things that I'm assuming that all of us here are aware of. I'm assuming that all of us here are aware not only of the English words that I am using, but also the fact that how to use a computer and how to look at how to read a presentation, etc. These are things that all of us are aware of, and therefore I do not go through that information in the sentence. And here is some examples of why this is so hard. So here is a statement, what a wonderful place to stay, and I can say that the sentiment is positive. And then here is a sarcastic sentence where we had cockroaches to accompany us in bed. Now there is nothing in the word cockroaches which say that this is bad, except from a domain knowledge where we understand that cockroaches in bed is not a good thing, but the sentence does not convey that information. And similarly, if somebody gives you tea in bed, it's not the same as cockroaches. The words may be very similar. In fact, they can be exactly identical. It could be we had cockroaches in bed, we had tea in bed, but the word cockroaches and tea convey different information because of the context that we know, the knowledge base, and this is very difficult to encode in artificial intelligence systems. I will not say this has not been done, but we are at a very, very primitive stage. So here are some real newspaper headlines. Now, the statement is, folks, baby steps on gates. But if you do not read with the proper pauses and the proper intonation, you may get completely different meaning. So here is another one. Scientists study whales from space, right? It is not, the whales are not from space. It is that scientists are studying from space, but it's a difficult one for even us to understand. This is something that I myself find it very hard because I never used an iPhone, and the context of that is very important on the tool. Also, it's not enough to search by keywords. Here is an example. This is something which is based on, but not exactly, on the way that IBM Watson won the Jeopardy contest back in 2011. So you have a question which is, in May, Portugal celebrated the 400th anniversary of the explorers' arrival in India in 1898. So there is a question, and how would you get a computer to answer it? The computer has scraped the internet and has got one factoid, one snippet of information, which says that in May, Gary arrived in India. They celebrated his anniversary in Portugal, and you would see that a lot of words match, and therefore you would think that a proper answer would be Gary. But of course, we know that's not the right answer. For this, what you would need to do is, there was another snippet of information, which says that on the 27th of May 1498, Vasco da Gama landed in Kapad Beach. This is another snippet of information you have. And then you are making a temporal reasoning by trying and calculating between May 1898 and 1498 and 400 years. You are trying and understanding the various different ways in which you would be using the same words that arrival in and landed in are very similar. And also you would need a geospatial reasoning where you would know that Kapad Beach is in India. So all of these come together, and only then would you be able to answer this. The point that I would like to mention in this example is that understanding language requires you to do a lot of different computations, and we as human beings have sort of do this without any awareness because of the millions of years of evolution. But this is not something which is easy to think about. So deep learning, and this is the heart of the artificial intelligence revolution. And people keep saying that, and when I open LinkedIn, I see that lots of people write lots of things on deep learning. When I open blogs and anywhere else on the internet, but a lot of people do not actually realize that there's nothing very, very magical about it. It is a bit of math and a bit of computer science. Again, as I said earlier, that there is certain parts which are inspired by the brain, in which neurons or nodes are connected with each other and interact with each other to complete a task. But unfortunately, this is where the similarity ends. The way artificial neural networks work is very different from the way our human brain works. Not that we know it fully, but we know it enough that it's not the way artificial neural networks work. So I talked a bit earlier about perceptron, and whilst I would not go into the exact maths, etc., but basically a perceptron is a computational algorithm which takes in 3 inputs, or maybe 4 inputs, or 50 inputs, does not matter, takes in multiple inputs and it tries and assigns weights to each of these inputs, such that when I take the sum product of W1 X1, W2 X2, and W3 X3, I add them all up, and if it is greater than 0, then I put in 1, otherwise I make it 0. So this is what a perceptron is, and when I showed the marked perceptron earlier, it's just how you would learn these weights. Now, a neural network is multiple perceptrons put one on each other with a nonlinear function in between, which helps you to sort of get any function that you would like to approximate, provided the function is continuous in nature. But that's all that a neural network is, and many people call neural network as multi-layer perceptrons. And a deep neural network has hidden layers, many hidden layers, where there is one input layer, there is an output layer, and multiple connections in between. And this is a deep neural network, and that's all that there is to deep learning. Deep learning algorithms use specialized, deep learning models use specialized algorithms like backpropagation, and many of you may have heard of the term backpropagation, to try and train the neural network. But there is nothing which is more, there is no sort of consciousness or intelligence in this. Looking at the evolution, what has happened in deep learning is that when you look at the beginning of artificial intelligence in 1960s, there was a view that you could have designed handwritten rules, and that would work to where you would make features using domain knowledge. When deep learning, the effort to put in the features have come down, though I would say that it's not as simple as you take a data and write code. There is a lot of thought which must go in, but in a very different way. Now, you would have heard of deep learning architectures, big terms, and people may be asking why is this so. So what are these? So, as I said earlier, that images have patterns, right? The color in a certain pixel of an image is in many cases related to colors in adjoining cells. Words in a sentence are dependent on each other. If I use the word I, the next word cannot be is. It can be I, it can be am, it can be will, but it cannot be is, because that's not correct language. There may be the sales in 1 week is dependent on the sales of the previous week. So all of these patterns in a text, in an image, etc., in data, require separate architectures. And also, although we will not go into the detail, there is a concept of parameter sharing, which makes the deep learning model have far more is able to process much larger volumes of data with fewer parameters. So there is a lot of theory here, and some of the most important deep learning techniques or architectures like convolutional neural networks, which are used for image processing, like recurrent neural networks or LSTMs, long short-term memory networks, which are used in text, then autoencoders, etc. You may see these words being bandied about in various different posts. And one must be careful to understand that there is nothing very fancy about it. We will not be able to go through the details in this session, but they basically are computational techniques to solve certain very, very focused problems. I would now digress a bit and try and see where have been some of the greatest success stories in in artificial intelligence over the last few years. Retail has been a great success story. Recommendation systems. We all have used Amazon, and we have seen that Amazon sends us recommendations. We've used Netflix, and Netflix sends us recommendations of movies. We are looking at natural language search and cognitive fashion, where your system would tell what you should wear with something else, what jeans would go with what shirt, etc. Retail has been also a place where artificial intelligence has been very successful. This is because of a combination of two things coming together. One is the availability of data, of course, but the other thing is that artificial intelligence systems are prone to make mistakes. But in most retail scenarios, I would not say all, but in most retail scenarios, the cost of making a mistake is much less than it would be in healthcare or finance. If the bank uses my bank account and tries to do artificial intelligence techniques and makes me lose money, I won't be happy and I would take very strict action. If someone uses artificial intelligence techniques and people die in healthcare, the cost is enormous. It cannot be quantified, in fact, by numbers. But in retail, if I get a few more recommendations than Amazon, I really don't care much. I may be irritated, but it's not that human lives are at stake or a lot of money is at stake. So the cost of errors being many orders of magnitude less, and the availability of huge amounts of data has made the success of artificial intelligence in retail to be very prominent. In telecom, there is also some success stories, especially in smart plans and AI-based network optimizations. Here also there is a lot of data. However, there is also a very strong regulator. The cost is much higher than in retail. And also there is in telecom, there are a lot of constraints by the science of telecommunications. So you cannot just get away with anything because of the way you or you cannot experiment too much because certain things are constrained by the network bandwidth, by the fact that you need to have acceptable error rates, etc. Healthcare is a place where artificial intelligence will, over the next 2 to 3 decades, make truly tremendous progress. And healthcare may very well be transformed beyond recognition 3 decades from now. But the cost of errors in healthcare being so high, with human lives being at stake, although there has been a lot of interesting progress and people keep talking about AI-enabled MRI scans and X-rays, etc., radiology. The benefits of that in actual practice is less because of the higher cost. Transportation is one which is very famous, with self-driving cars becoming the hot topic of the last 2 years, especially last year, and then there are other areas like safer vehicles, etc., using artificial intelligence. Education is another field where I think that artificial intelligence would be very, very useful. When people teach, when I teach at a couple of IIMs as a adjunct faculty, visiting faculty, I teach and all our professors taught at the median of the class. So that the most brightest student would have thought that this is simple enough. whereas the student who was having the most difficulty would have thought that this is difficult. That's because, and that's the only way you can sort of make everybody at least partially happy or partially unhappy, depending on how you put it. Possibly the artificial intelligence would be able to change this, and everybody would be taught at their own pace. Again, the cost being so high, and the complexity of human speech and the complexity of teaching, the progress is limited, but there is significant progress happening or there's significant scope of progress happening in AI in education over the next couple of decades. Public safety is another place where there may be huge success stories lined up, especially in smart surveillance and cybersecurity. Again, the cost being high and also the complexity of the problem. You are having a CCTV camera which is watching a railway platform, and then there is a gentleman who comes in and puts down the suitcase because it is too heavy. It's very difficult to understand whether he has put down the suitcase because it is too heavy, or because it's a terrorist who keeps the suitcase and wants to run away. This is not such an easy problem to decipher using any algorithm or even for a human being. And so there are fundamental challenges, by the way. You can have predictive smart surveillance, but there is huge scope of success in the next couple of decades. I'll come to the last section. Where are we on AI? I keep saying that there are lots of things. One thing is very sure: supervised learning won't work. And why is this so? Because when my son was about 1.5 to 2 years, I maybe showed him one cat and told him that this is a cat. And after that, he has been able to identify cats in all sorts of positions: walking, sitting, climbing a tree, etc. The human brain, and also to a large extent, to whatever our experiments say, animal brains can learn from extremely small amounts of data, and by drawing inferences from extremely small amounts of data and correlations. This is not so easy for the state of the art artificial intelligence we have. We can never have training examples of all possible cases, and too many examples are required for good classification. For all the problems that you would see that are placed in AI training sessions, where you see a deep learning model getting 99% accuracy, for all the LinkedIn posts that people would talk about the brilliance of AI solutions, etc. Many of us who work in the field will know that trying to do something very simple like predicting the pattern on a t-shirt is a very, very difficult problem to solve. Although this should be a cat and dog sort of classification problem. It's not easy. And I say this because just before this meeting, before this webinar, I was on a meeting with a few of my colleagues, and we were trying to figure this out. We're getting poor accuracy from a state-of-the-art neural network. And this is what's not told, that the results that you see on research publications, the results that you see that are published by companies are all the success stories, right? There is a cherry picking and a sampling bias happening. All the ones which did not work are never reported. There is no common sense. Artificial intelligence does not understand that certain things don't happen. A baby of even less than 1 year, if he sees a picture of a car in the air, would start laughing because his or her common sense says this is not possible. Giving it to Google or a Microsoft image annotator would say a car flying in the air, and no surprise that this is something absurd. There is no common sense that is kept there. Common sense is the ability to be able to infer the state of the world from partial information, and that's something that's not there in current AI systems, and not only we are a long way from it. What is very clear is that we don't know even how we would get there. There is some hope today on reinforcement learning trying to solve some of the problems. There is some hope of unsupervised learning solving some of the problems. But the current state of the art artificial intelligence has no way of figuring out how does one tackle these very, very difficult problems. And this is something which is really needs a significant breakthrough, and more of deep learning won't solve. Challenges and risks within AI. One of the ones is job losses. That is going to happen because but this is not something to be worried as such. Many of the jobs that people used to do 100 years back no longer exist. Many of the skills that were very important, like typing, like calligraphic writing, have either not important or are very, very niche application areas, but not in general. So this has happened, but the impact here may be wider because of the fact that we would be replacing human mental labor with labor of machines. There would be societal changes between the difference between the haves and the have-nots. And these are challenges that one must be very, very aware of. And and this is a fact that there is not enough awareness in the public sector, in the governance on how to tackle these problems as they come up in the next 10 to 20 years. There is there's a huge risk of AI being used in warfare in a more sophisticated way than currently, security breach using AI, etc. However, to claim that robots are out there to get us, I don't think that's going to happen anytime soon, and it doesn't mean the general consensus in the field of the specialists in artificial intelligence makes it clear that it's not going to happen anytime soon. So yeah, that's not going to happen, but the huge impact of artificial intelligence over the last 5-7 years, and that would continue on the next 2 to 3 decades, is going to change the world in ways that we cannot even think of. So I'll stop here now, and I will any comments and questions I'm seeing. Some questions on the chat, but so let's take these questions first, and then I'll also open the house for any questions people may have. So Madhav has said that sarcasm detection by Elvis Saravia presents a CNN approach for the problem. Well, I'm not aware of at the top of my head of this approach, but there has been success in sarcasm detection, no doubt about that, and in some areas significant success, but that does not mean that we've solved the problem. That's a long, long way to be able to really understand. And sarcasm is the least of the complex problems in text to in human natural language conversation. The most complex problem is trying to look at the things that I showed in the keywords slide, where you would need to have contextual understanding. You would need to make spatio-temporal reasoning, and those are very difficult. There's practically no way known today to solve them in a generic way. You can perhaps have a very specific problem tweaked to make it work, but there is absolutely no generic way to solve this. From the point of taking a solution to the market, Madhav's question, would you suggest working on an AI use case and then take it to the client, or how do I sell the idea to the client? A consultancy approach is a well-suggested way, but the industry still treats AI and ML as a cherry on the top rather than an actual revenue-generating way. So let me make a few things. I do agree that in most organizations, artificial intelligence is not even a cherry on the top. It's something like you would demonstrate for the purpose of because it's very fancy and would catch your client's eyes, but not actually implemented. This is changing. I am currently working with Indians, even in India. I'm working with fashion retailers. I'm working with distribution sector companies. I'm working with media and entertainment companies who have very strong use cases in artificial intelligence and would like to go live with it. I would say that AI starts with a POC. So you speak with the business and you get an idea, but then you go and prove it on a small restricted solution. And then you slowly, step by step, generalize it. It's very easy to have a solution which or have a use case which looks perfectly solvable, but you make a slightest of change and it becomes an unsolvable problem. So there are lots and lots of such cases. So POC is almost always the way to go. Are there any already implemented use cases that are out there and working very well? Yes, lots and lots of use cases. Almost all of the interactions that you're doing with your mobile phone using text-to-speech, speech to text when you're speaking to the phone is artificial intelligence. Amazon is artificial intelligence. We are all AI. We are all consumers of artificial intelligence. So yes, there is a huge amount of success stories in artificial intelligence. Last year, I worked with a South Korean client to build a conversational recommendation system. I'm working now with a number of fashion retailers. So there is huge success stories in almost all the application areas that I talked about. But there are huge limitations and only under certain constraints that they work. In a real-world scenario, is supervised learning better or unsupervised better? Unsupervised learning is perhaps what would finally be the way to solve the more difficult AI problems. But the success of unsupervised learning today is very limited. The real success stories that we hear of and the real success stories are almost exclusively in the supervised domain. The only major exception was the AlphaGo, which in last year, 2017 March, defeated the top Go player in the world. That is a deep reinforcement learning, which is a different variant and is not supervised learning. There is reinforcement learning, of course, in autonomous cars, etc., but the majority is supervised. What do you think of the impact of AI in manufacturing and hardware industry, which is somewhat of an uncharted area? I would not say so. I did not mention it yet because It's not somewhere where I've had a lot of experience in, but you would have to remember that predictive maintenance of devices goes back many decades, and especially with the Internet of Things and connected vehicles, there is a lot of success stories, limited success, yes, but success stories nonetheless in having artificial intelligence come into for crashes in cars, etc. So yes, there is, but not too much. How will AI and ML help us in semiconductor and chip development domain? I'm very sorry, this is not a domain that I have much experience on. So while there would be undoubtedly use cases here, I would not know of them offhand. If there is a serious interest, you can reach out to me separately, and I can try and get you in touch with experts in this field. Is there any research happened in 3D shape recognition using AI? I work computer-aided engineering field. We work visual simulation, which will change with shape change of object. There is some research work happening in 3D shape recognition and making of 3D shapes, etc. Looking at how would a certain clothing item fit you, etc. These are very experimental in nature. Then you would see certain demos, not very production worthy, but demos or nice to see things. The challenge is not 3D. The challenge is simply the complexity that you would need to handle to make 3D work in a reliable way is very large. A common keyword across many analytical AI is algorithms. Would you be able to elaborate a bit more on what does this mean and for a novice? And are there any? Okay, so an algorithm is basically a set of rules which make you solve a problem, right? Making bread or roti is also an algorithm. When we look at traditional IT development, algorithms are predefined rules. So your income tax calculation would be a percentage of your income after deductions and standard deductions, your investments, etc. Now, when you start getting into the field of machine learning and artificial intelligence, you do not know what is an algorithm. You cannot tell me the steps that are required to identify my face or from whatever hits your retina. So therefore, what we would need to here look at is statistical techniques by which you will see what are the features that define Sujoy as different from say Sachin Tendulkar, and being able to recognize it. So these techniques are able to identify patterns which would be able to differentiate between different objects. With recent Pramod says, with recent advances in computing power, the capabilities of machine learning and artificial intelligence algorithms have improved immensely. In the case of AI making autonomous decisions in warfare, would we be comfortable delegating all decisions to the algorithm? No, we would not be comfortable delegating decisions to the algorithm. One thing you would need to realize that warfare, a lot of it is posturing. A lot of it is positioning ourselves. And that is one of the serious concerns, one of the really serious and unknown of how to tackle the use of warfare of AI in warfare. What's your opinion on the ethical and moral consequences of delegating decisions to these algorithms? Well, there is a huge amount of ethical and moral consequences of not only in warfare but also in other issues like information and the way it is able to practically know where I am at any point of time. There are serious AI ethical issues which need to be solved to make over the next decade or so. How can we implement 3D semantic modeling? Sharvik, I'm sorry, I'm not very clear on this. What is it that you are trying to explain to query on? It's not something I'm aware of. Again, if you have any details, I'm happy to take that with you offline over email. If you have very less training data, can AI be used? Yes, it can be used. And what you do is in such techniques, you try and do something called transfer learning, where you try and use similar models which other people have built on say, image recognition. Take that model and try and apply it on your data. The success may be limited, but it would be better than not having any data. But yes, in general, the success is more on the limited side. Is there any correlation between big data and AI? Well, big data is more of a technology stream where you could be able where you would need to process large volumes of data. AI requires large volumes of data, so for many AI systems have at their back-end big data systems. But from a principal view, they are very independent of each other. However, when we are talking of big data in terms of distributed computing, there are different challenges which need to be handled for making artificial intelligence run on a distributed computing environment. So yes, there are relations between big data and AI, but it is not that one is causing or even directly correlated, let alone causation between the two. So any further questions or comments from any one of the participants? Sushma, anything from the host side which you would like to point out? Hello? Yes, I will share the PPT with Sushma. So do we close the session?
Hello? Sir, if you are done with the questions, we can close, sir. Are we done?
Yeah, we are done.
Okay, sir. Then we can close the webinar.
Thank you.
Yeah. ಚೆನ್ನಾಗಿ ಮಾಡ್ತೋಯ್ತು ಯಾವಾಗಲೂ ಹೇಳ್ತಿದ್ದೆ ಇವತ್ತು ಯಾಕೋ ಮಾಡ್ತೋಯ್ತು